Hello, we are Group 17 and this is our final project for machine learning. For the data, we select a classical E. coli dataset, which is Escherichia coli. It's a bacteria that almost all our body has and helps our digestive system. Now, for the variables, in this dataset we have 7 variables. These 2 variables are single variables. These 2 are binary variables that have to do with the proteins in the bacteria. And we have these 3 variables which are scores. When we check for dimensionality and distribution, we can find out a lot about the variables. First, these 2 variables, you can see that they are binary. Then we have that most of the variables are bimodal. And then we can see that the variables, they reach from 1 to 8. That's their target. Being 1 the longer one because you have 2 variables that are binary. Then, when we review the data, we can figure out that when check equals 1, and they show a standard behavior with the other variables. And this can be impactful for the data analysis. So we decide to remove the check equal 1 from the dataset. Now we have a new distribution, and when we ask the code for empty spaces in the dataset, we found that there is none. So we can conclude that there is no ends in our dataset. Now let's talk about the correlations. Correlations between AMP1 and AMP2 demonstrate a high level of correlation. This is because both of them are scores. Then between LEAP, GIGS, and MCE, we have medium to high correlations, and then we can the rest of the variables, they don't seem to have a lot of relations. That's why we did this to check for all the variables, and we can see that there is not a highly correlation between the variables, but there is a clear separation between the classes, which is important for the classification task.
The first component captures a 0.37% of the variance, while the second one only a 0.23 of the variance, and the sum of both is of 0.6% of the variance. Okay. Then the residual 2 components individually, they capture 0.17 and 0.14, and the sum of the both variables, the first one and the 2 residual 2 components, it's a 0.1 or 0.9%. Sorry, 0.9. Okay. Then in supervised learning, as we know, we have the method of Cummings and agglomerative clustering, and the silhouette score for Cummings shows us that we have a 0.38, and in the silhouette score for agglomerative clustering we have also a 0.38%. Okay, that's the same number. They differ in the last numbers. Okay, one is 6 and the other next is 7, and then the optimal number of clusters, as we can show here in the graph, is of 4 number of clusters. Okay. Then we also have in the relevant variables of each cluster and confusion matrix cluster, we have a lot of data. Okay, in the cluster for centroid MCG is of minus 0.77, and in conclusion, the most relevant variables for the cluster generation are the LM1 and the LM2. We have seen before in the correlation that they are the high correlated, and each cluster represents chemical relationship. Okay, so that's important because if not, we don't know where is the relation between them, and we predict that the cluster instead of the target variable, and the model that also is very good in predictions of the clusters. Okay, in the supervised learning, we know that we have to be accuracy, precision, recall, and F1. We have to make them a study of them, and we know that the KNN is the most accurate, the most precise. Also, the recall is the higher, and the F1 score we have also the higher. higher than in the random forest, and the XGB boost is going to be our last one. Okay. Then in the smooth, we know that is to diversify. We know that the small is to diversify the data set with synthetic samples and hence robustness and generalization in the models. And here we have the contrary of the before, that we have the XGB boost as the higher one in accuracy, precision, recall, and F1 score, and the KNN the last one. Okay, in conclusion, okay, we have that in the data there are variables that are mostly continuous, except for link and TAH, okay, that they are binary. Then lead ranges are from 0.48 to 1, and T is from 0.5 and occasionally 1. Disparity in instance for classes within these variables, and a scarcity of values equal to 1. Then in PCE analysis, we know that the first two components account the majority of the variance in the data, summing up to 0.1%. And in correlation, we know that LM1 and LM2, as we have before said, they show a high correlation. The target variables are MCG, G, V, H, and LIP, and there is no evident correlation among the remaining variables. And as we finally saw in the unsupervised and supervised learning, we have that in K-means it's slightly better with a silhouette score of 0.38, and the optimal clusters are 4. Also, we know that XGB boost performs best in supervised methods, and achieves a score of 0.99 in the F1, okay, and accuracy of 0.99 after applying a smooth, okay. Thanks